we had covered a few questions. I think up till question number 5. So, up till question number.
Yeah, we stopped at 5.
So starting from question number 6. I said, can you figure out the shape of these molecules?
It's trigonal and non-linear.
No, this one is pyramidal. The first one is pyramidal. And the reason it's pyramidal is because H3O plus 1 looks like this. That H3O plus 1 looks like this. That it's got 2 H atoms bonded to it. And there's a dative bond as well.
Oh, okay.
So it's still got a lone pair. So it's basically 3 bonds and 1 lone pair, right?
Yeah, so it's pyramidal.
Again, the angle would be 107. That would be non-linear because sulfur has 2 lone pairs. So this one, when an evacuated tube, so this is PbGO-nRT. So what is the identity of gas? So you just have to plug the values. Use your calculator to figure out the MR of this gas.
I got the MR as 40. So it's argon.
What's the MR?
40.
Yeah, so it's going to be argon, right? You can just make sure when you're using PbGO-nRT, make sure the units are correct. Now you've got nitrogen and carbon monoxide both have MR equal to 28. And the boiling point of N2 is 77 kelvins. The boiling point of CO is 82 kelvins. What could be responsible for this difference in boiling points? So they both have an MR of 28. So why is this having a higher boiling point? Well, what intermolecular forces are going to exist between N2 molecules and CO molecules?
N2 has induced dipole forces. CO has both induced dipole and permanent dipole.
Because the CO is polar because oxygen is more electronegative. So this one is going to be slight negative. This one would be slight. So it's going to be polar as well. So which one is the correct one? It's A, right? I mean, it is A, right? Because the others, yep, they also have the same number of electrons. So the MR is the same. So that means they're going to have the same van der Waals forces, but one of them is going to have permanent dipoles. Which statement about enthalpy changes is correct? Is the first one correct or?
First one is wrong.
Okay, so enthalpy change of reaction is basically enthalpy change of any reaction. It could be positive, it could be negative, it could be both. What's enthalpy of combustion always?
It's negative.
Because it's always negative. What's enthalpy of formation?
Formation.
When you're
It's
forming,
not always positive.
it could be anything. It depends. Because when you're forming something, you're doing both. You're breaking bonds. For example, if I want to form water from its elements, then it would be that this is going to be the reaction, right? And in this reaction, you'll be breaking bonds, and then you'll be forming bonds. So it will depend. Whichever, if stronger bonds are formed, it's going to be exothermic and so on. So it could be both. And enthalpy change of neutral, that's the last one is always correct. It's always, and what is the value always? Whenever something gets neutralized, when you have an acid-base reaction. So what is the value? What is the exact value? Any idea? Whenever you have an acid-base reaction, then your enthalpy change is always around minus 57 kilojoules per mole. Per mole. And if it's a weak acid or a weak base, then the value is slightly less. Okay, is that clear?
Yes.
So what is the enthalpy change? What is the definition of standard enthalpy change of neutralization?
It's the enthalpy change when 1 mole of water is formed. It's which one?
When an acid and a base react. So I think it's going to be D, right?
Yeah. It's
When
D.
an react together to produce 1 mole of water. And remember, it's always going to be, for strong acids, it's always going to be minus 57. Strong acids, strong bases. You've got this reaction. He says that this kills bacteria. Which statement about this reaction is correct? Chlorine is both oxidized and reduced.
It's both oxidized and reduced.
Yeah, that does happen because chlorine is 0 over here. What is the oxidation state of chlorine in HOCl?
It's +1.
Here that's +1, and over here it's again -1. So it's getting oxidized and it's getting reduced. As the next one, you've got this enthalpy change. You want the equilibrium to shift to the right. How would you do that?
Lower temperature and higher pressure.
Okay, so the exothermic reaction is favored at lower temperature, and higher pressure favors less gas mole side, which is the forward side. So now you have to figure out the value of Kp. And I think what is the equation? He says equimolar mixture of H2 and I2. So I think the reaction is that it's H2 reacting with I2. And together they're forming HI. Now, he says that an equimolar mixture of H2 and I2 react together. The mole fraction of HI in the final mixture is X. So what is the equilibrium constant Kp for this reaction?
We have to find the partial pressure. First, we have to find the number of moles at equilibrium.
So how would you do that? I mean, this is a difficult question. Try and think of how would you do that? And he hasn't even given you the equilibrium moles. You don't know the initial moles? Do you remember he didn't give you the initial moles. He
Yeah.
didn't even give you the equilibrium moles. The only thing he gave you was the mole fraction. Which he says that it's X for this one. Now, can you think about what the mole fraction of the other two is? So what
Shouldn't it be X as well?
shouldn't it be what?
X?
What H2 and I2?
Yeah.
Like the initial moles? I said let's give X a value. Do you know what the mole fraction is? Mole fraction is the percentage. Do you know what the mole fraction is? Mole fraction is the fractional percentage of a gas present at equilibrium, right? Do you understand that part?
Yes.
So let's give it a percentage. Like this is 40%, right? Like mole fraction would be 0.4, right? Mole fraction 0.4 means that 40% of the gas that is present at equilibrium is HI. Is that clear?
Yes.
So what would be the percentage? So the total would be 100%, right? So that means the remaining 60% of the gases are these two, right? Is that clear?
Yes.
And since it was an equimolar mixture, these two were present in the same quantity, right? So
So
that
they're 30 and 30%.
yeah, so whatever happens, whatever forward reaction or backward reaction happens, they're going to remain equal, right? Because they react in 1:1. So even at the end, they will still remain equal. So it's going to be 30% this and 30% this, right? Is that part clear?
Yes.
So in terms of mole fraction, this will be 0.3 and this will be 0.3 and this will be 0.4 because mole fractional is the fractional percentage, right? So this will be 40 out of 100, this will be 30 out of 100, this will be 30 out of 100. So this is important. You make sure you know what a mole fraction is. It's just the fractional percentage. So if you have 40% of this, then the remaining 60% would be these two gases. And since they're reacting in equal ratio and they were initially added in the same ratio, so they would still remain equal. Whatever the amount is, they would still remain equal. So now do the same thing, but this time, instead of 40%, this is X. So, and remember, this is X. So, and this is
So
out.
this is one, this X over 2.
Yeah, what would this be? I mean, what would be the remaining percentage if that is X?
It would be 1 minus X.
So the total would be 1 minus X, right? I mean, the total,
Yeah.
because fractional percentage is out of 1, right? So out of 1, if this is X, that's going to be 1 minus X. And since it's going to be equally divided between the two, so what would that be? So it's going to be 1 minus X divided by 2 for H2 and 1 minus X divided by 2 for I2. Is that clear?
Yes.
So now you have the mole fraction. Now one more thing. What's the expression for Kp? Kp would be PHI squared.
Yes.
That's going to be divided by what? pH2 and multiplied by PI2, right? So how do you find partial pressure? What do I do? What do I multiply the mole fraction with?
By the total pressure,
And we don't
which
have,
is not given.
which is not given. So I'm just going to call it P. right? And this is also the P is irrelevant because you've got equal number of terms in the numerator and denominator. When you have equal moles on both sides, the P would get cancelled out anyways. So the P is kind of irrelevant in this case. So it's going to be x squared. And at the bottom, you're going to have 1 minus x divided by 2. And that will be into 1 minus x divided by 2. So that's going to be squared as well, right? So if I simplify this, bring the 2 in the numerator, it's going to become 4x squared divided by. So I think it's C, right? Is that clear?
Yes.
So just a. So this wasn't an easy question. I mean, most people would not get how to do this one. But so remember what mole fraction means. I mean, probably you're not going to get this difficult a question. So let's move on to the next one. I say in reaction 1, a student measures the initial rate of production of CO2 when COCO3 is added to nitric acid. He didn't tell us whether it's excess or not. In reaction number 2, the student repeats the experiment using a higher concentration of nitric acid. So the previous reaction was that the concentration was lower, right? Over here, the concentration is higher. And he's using the same mass of copper carbonate. And he said the acid is in excess. And samples of the same CuCO3 powder are used. So that means CuCO3 is not a factor. It's in excess. And it's all in powdered form. So the acid is in excess in both cases. So who's going to have the greater rate of reaction?
Reaction 2.
So reaction number 2. So what will be this fraction?
Then it would be greater than 1.
Greater or smaller?
Oh no, less than 1.
I mean, so it's clearly because it's got a higher concentration that's faster. So reaction 2 will have a higher rate. So the denominator is bigger, so you'll have a faster reaction, right? What about the next one? Initial number of effective collisions in reaction 1 per second. Initial number of effective collisions in reaction number 2 per second.
For 2, it would be more, so it would be less than 1 as well.
I don't know. I mean, both these things kind of mean the same thing, right? So that just means you got a faster reaction. Let me just double check this. I mean, it's obviously going to be T, but this was 14. Yeah, it's T. But this one was pretty obvious. It's the same as the first one. The forward reaction of a reversible reaction is exothermic and has an activation energy of plus 30. The reverse reaction proceeds by a mechanism that is the exact reverse of the mechanism of the forward reaction. So we can kind of sketch the energy profile diagram for this. Remember, it's an exothermic reaction. So what will you have? It's so for an exothermic reaction, this is how. That's your reactants, that's your products, right? And he says that the activation energy of the forward reaction is plus 30. So this over here is plus 30. And he says the reverse is, the reverse is exactly, so everything is exactly the reverse. The reverse reaction is exactly the same. So which statement do you think is correct? That's the only information that's given.
Is activation energy the same?
For the reverse reaction, the activation energy would be this. I mean, you have to climb all the way up, right? So it's obviously going to be different.
So it's greater than.
Yeah, the activation energy for the reverse reaction is greater than 0. This is also incorrect. It's greater than 30, right? Yeah, so it's D, right? Is this clear?
Yes.
Now, in organic chemistry, X, Y, and Z are elements all found within group 13, 14, and 15 of the periodic table. X is in the same group in the periodic table as Y. And Y and Z are in period 3. So Y and Z are like somewhere in period 3. While X is in the same group as Y. So X, we don't know what the position is, but they'll probably somewhat be arranged like this. Now he says the first ionization energy of X is greater than the energy of Y. So what is the relative position of X and Y in the group?
X comes first and then Y.
Okay, so that indicates that X is a smaller atom. And the melting point of Z is less than the melting point of Y. I don't know what that information tells you. Is Y to the right or Z to the right in the periodic table or Z to the left of the periodic table? Where do you think Z is relative to these two?
I mean, it depends, because if it's like group 14, then it's silicon. So
It depends a lot. I mean, it's like if these were metals, silicon, then Z would have a higher melting point, right? If this was like carbon and silicon, I mean, yeah, this one doesn't really tell you much. I said, what about Y and Z form both chlorides with whites, which are white solids? So I said, both Y and Z. I said, wait a second, Y and Z are in the same period, right? So Z is in the same period. So X
So
is,
we're talking about group 14 and group 15 because they have pH less than 4, so they're acidic. It can't be aluminium.
yeah, so they've actually limited it. It's group 13, 14, and 15, right?
Yes.
So one of the groups is missing. So they both form, who forms white solids?
Both silicon and phosphorus. Wait. Yeah.
Silicon and?
Phosphorus.
I said, they didn't tell us, I said, they did say that it's in period 3. So Y and Z, so this is period 3, right? So silicon has a chloride, which is not a white solid. You said silicon? Silicon chloride is not a white solid. Aluminium chloride is. And PCl5 is a white solid. Silicon chloride is a liquid. Is that clear? Like if you look at the chlorides,
Yeah.
so just remember that silicon chloride is a liquid. It's a colorless liquid. Phosphorus PCl5 is a white solid. So I guess this is phosphorus and this is aluminium. These white solids react with water to produce a solution, so they are acidic. Both of them are acidic. They both hydrolyze and they form acids. Which row in the table shows the possible identities of X and Y? So Y is, yeah, I guess it's going to be A. Is that clear?
Yes.
So I think the key was this thing. And let's double check the 16A. Yeah, 16 is it. As the next one, which row about silicon and magnesium and the iron is correct? Again, they are in the same period.
First one is wrong. Silicon has a smaller atomic radius.
Okay. Second is right?
Yeah.
This one is wrong.
Lower melting point is wrong. And same thing.
Both is correct. Like the radiuses decrease when you move to the right. 12 protons, 14 protons. They have the same number of electrons. Like this is going to have 10 electrons, 4 plus. This is also going to have 10 electrons if it's 2 plus, right? So because the higher protons, the electrons are going to be more strongly attracted. So the radius is going to be smaller. So option D over here, the first column, is correct as well. So let's look at the explanation. What do you think? Is this explanation correct? I mean, silicon does not conduct electricity. It's a semiconductor, but it's got less. I mean, it doesn't have It's not metallic. It doesn't have delocalized electrons. So this explanation is correct. Jody, is this clear? Clear? Hello, can you hear me?
Yes, I can hear you.
It's the next one. But is this question clear?
Yes, it's clear.
As the next one, there's an acid-base indicator. It's below a pH of 3.8, it's yellow. Above a pH 5.4, it's blue. Between these values, it is green. How is it changing? It's changing from yellow. Between the values, it's green. And above it, it's blue. Above what? I think 5.4. Below 3.8. So it's added to an aqueous solution formed when the chloride of element T is added to water. The color becomes yellow. So T is, I mean, the chloride of T, right? That is definitely acidic, right? When an excess of solid oxide of element U is slowly added to the yellow solution, the indicator turns green then blue. So that means this oxide is basic. So the oxide of, so it must be basic because it makes it turn blue. So what are element U and element T?
U is phosphorus and T is silicon.
No, basic. Silicon is fine. Silicon is acidic.
Oh, U is sodium, I mean.
Okay, so sodium oxide it will form sodium hydroxide, which is the base. Silicon chloride will hydrolyze and it will form what? When you mix it in water, it will form silicon hydroxide or oxide. Plus, it's going to form cubes of HCl. Next one, which law directly describes the separate reaction of calcium and strontium with water? So calcium is higher up in the in the group. Strontium is lower down. So which one do you think is going to have a faster reaction?
Strontium.
Okay, so down the group, the reactivity increases in group 2, so strontium is going to have a faster reaction. So it's going to be this, right? So when they react, who gets oxidized and who gets reduced?
The calcium or strontium is oxidized.
Yeah, so they lose electrons, they become ions +2. And who gets reduced? That's water, right? So, and specifically it's H because H is +1 in water and over here it's 0. So that is the substance that is getting reduced. So L and M are both compounds of group 2 elements. L and M are both soluble in water. So group 2, right? And they're compounds and they're both soluble in water. When solutions of L and M are mixed, white precipitate is formed. So which one? So they're both soluble, but when you mix them, they form a white precipitate.
It's A, barium sulfate.
Yeah, these two are soluble. Barium sulfate is not soluble. Carbonates are not soluble. And when these two mix, the sulfate ions and the barium ions will form BaSO4, which is then soluble. They'll form a precipitate. Over here, no combination of the ions will form something that's insoluble. Barium chloride will also be soluble. Magnesium nitrate would also be soluble. So they will not produce any precipitate. Option C. Actually, this one, try doing this one. A 5-gram sample of a group 2 nitrate loses 3.29 grams in mass when heated strongly. Which metal is present? How would you solve this?
I can write the general equation for the decomposition of nitrates.
Okay. What's the general equation?
2MnO3 forms 2MO plus 4NO2 plus O2.
Yeah, I didn't get. Can you repeat it?
I'll represent the metal as M, so it would be 2MnO3.
Okay.
It would form metal oxide, so MO,
Achha, I
and
thought.
4. Oh, yeah. I multiplied the equation by 2.
Achha, okay. But this is fine as well, right? So that's your general equation. What are you going to do next?
The 3.29 is the mass of the metal oxide. And 5 is for the metal nitrate. And the moles of the metal nitrates and oxides are equal. So we can equate them to each other if we divide by the MR.
The MR is going to be M plus 124, right? It's an M. And it's
Yes.
16 times 3 twice, so that's going to be 124. So those are the moles of this, and the moles of this will be.
M plus 16.
And according to the equation, the ratio is exactly the same. So these moles should be equal to these moles. So can you try and solve this? I mean, if I equate the two moles, it's going to be 5M plus what? 16 times 5, that's 80. And 3.29M plus 124 times 3.29. And then we can have M to one side. So that's going to be 1.7M So it's going to be 124 times 3.29 minus 80. So what do you get for M?
I got 191.7.
How much?
191.7.
I don't know what.
No, I think I did something wrong.
Probably, I think, because I don't think there's anything 191. Barium, I guess, is the
Is,
biggest.
is it 39.5? Because I tried with like different values. So then it would be calcium, I think.
Okay, so you're getting calcium?
Yeah, but like I had different values.
Okay. I mean, let's double check this. Is this calcium 21, right? Yeah, it is calcium. I say, anyways, next one. In this question, Q represents an atom of chlorine, bromine, or iodine, which explanation for the variation in volatility. So why is the boiling point increasing down the graph?
It's A, the instantaneous dipole-induced forces.
You can see you got more instantaneous dipole induced dipoles. You got more electrons, bigger molecules. Which statement about halogens or halides is correct? Is the first one correct? Do bromide ions form a white precipitate when you add silicons?
They form a cream precipitate.
That's wrong. Bromine does not oxidize chloride ions. Is that true?
Yes.
So that's the right answer, right? Uh, so that's it, right? So the others are wrong. Iodide is the best reducing agent, so the others are wrong. So this one is. Can you try and figure this one out? This is the latest paper, but they're repeating a lot of old questions. Now he says ammonium cyanide is heated in the absence of air. The only part of the reaction is. So ammonium cyanide is heated, and the only product of the reaction is CO. So it's not, it's C and oxygen. CO NH2 twice, right? No other products are formed. So what is the formula of the cyanide ion?
Is it C?
Yeah, it is C.
I did it by like trial and error.
Basically, you just have to balance it, right? I mean, this was NH, I mean, this was ammonium ions, right? And cyanide ion was X, right? And it was decomposing to form what? CO NH2 twice, right? So you just have to like balance it, because there are four H's, right? So there's the possibility of only one ammonium ion. I mean, you can't have more than one ammonium ion on this side, because on the other side you just have four H's, right? So if you put in one ammonium ion, the H's are already balanced. What's left? there is C left and there is O left and there's one extra N left, right? So there's C left and there's O left and there's one extra. And since this has a +1 charge, so this one must have a -1 charge. So that's why it's going to be C. Is that clear?
Yes.
And so what's the empirical formula of this compound? How many carbons do you have?
6 carbons.
So that's yes, 6. And each one has I think 2 H's, right?
Yeah. So 12 hydrogens.
So 6 carbons, 12 hydrogens, and what?
4 nitrogens.
So what's the empirical formula? That's going to be divided by 2.
It's B.
So it's going to be B. As the next one, you got this compound. It says that aspartame is chiral. How many chiral carbon are present in this molecule? So how many chiral carbons do you have? I mean, the double bonds are not chiral, right?
Is it 2?
Yeah, I think this is chiral, right?
Yeah.
And this is chiral. That's the only thing. 2 carbons. Because this carbon is not chiral because it's got 2 H's. This one is not chiral. The others are also not chiral, so I guess it's 2. How many sigma and pi bonds are present in this molecule? So you just have to, I guess you have to draw this. So CH. Then there's another C. Then there is CH2. So then you have another CH2. Then you have another CH. And then you have a C with 2 CH3s. So now tell me how many double bonds have I missed? Like I've just written this down. So where should I put the double bonds? Because the bonds are not complete for this carbon atom. There are 2 more bonds, right? So I guess this one is a triple bond, right?
Yeah.
And there's a double bond somewhere else as well. I think this carbon is not completing its bond. So there must be a double bond over there as well, right?
Yes.
So pi bonds, I guess there are 3 pi bonds. One over here and 2 over here. And the rest you can count the sigma bonds. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's going to be D. Is that clear?
Yes.
The hydrocarbon C7 can be cracked. Which compound is the least likely to be produced in this reaction?
D.
I'm just thinking about this. C17H36, right? Now, what's the difference between this and this? Like there's a difference of
CH. That's not an alkene or an alkane, so it
it
can't
can't
be formed.
so that can't be formed, right? I mean, when you crack it, it breaks into 2 pieces. So if I crack it into this, the other piece is this, which is not possible, right? So I think that is D. Is this clear?
Yes.
Which compound has an MR of 84 and would react with HBr to give a product of MR 164.9? So I mean, these are all going to react with HBr except for the first one. Ketones don't react with HBr, right? So I guess you just have to figure out who's going to give you 164.9. For that, you would have to first figure out what the MR of this thing is. That's 1, 2, 3, 4, 5, 6 carbon atoms, and there are how many H's? There are 12 H's, right? It's an alkene. So you add the HBr is going to get added over here. So you add the HBr and find out what the I don't know. I said that is giving it's 80 around. Br is around 80, right? Can you figure this out? This is 72, this is 12, this is 1, and this is 79.9. I think this is the answer, or maybe
Yeah, it gives 164.9.
that's the answer. You've got this molecule, and he says that it's oxidized. And it's strong oxidation, right? Now, what happens? What happens in strong oxidation? It's so what happens in strong oxidation is that all the double bonds are going to break, right? So these are all. So you're getting a lot of products. I don't know why this paper is every question is time consuming in this paper. It's as I say, you're getting a lot of products, and you have to figure out each one of them, like who forms what. So we have to. I mean, you have to do it for each one of them because then you have to This takes a very long time. I mean, there's no shortcut to this question because you have to count all the products. And you get one wrong, the answer will be wrong. I'm going to. So the middle part goes, the double bond breaks. You can remember I have to count the molecules as well. So all these double bonds have broken, right? Now I have to figure out, would I have, like the first one over here, would I have a ketone group? I will have a ketone group in this, right? 2 carbon chains, it will turn into a ketone. Is that clear?
Yes.
Over here, would I have a ketone group? I think this one would be a ketone, right? This one would be a carboxylic acid. 1 carbon chain, that's a carboxylic acid. 2 carbon chains, that's a ketone. This one is, both of them would be carboxylic acids because they both have 1 carbon chain, right? This one will be a ketone, right? Again, both of them would be carboxylic acids. They've got 1 carbon chain, again, carboxylic acid. This one would be a ketone, right? This one. Again, this is going to be carboxylic acid. This one will have a ketone. And the last one over here would also have a ketone, right? So that's 1, 2, 3, 4, 5, 6, 6, right? Is that clear?
Yes.
So this one was, I mean, this one was a difficult paper. It was taking like each question took a really long time. So I'm just going to post it, keep it here. So we're going to start with question 30 onwards in the next class. Is that clear? All of it.
Thank you.